Today we will talk about the grout pile dilemma. Here you could see there is one discussion in the geotechnical engineering form. You can see John is asking, "Sir, I have been going through these pile design documents all morning, but I still don't get the whole grout rock bond thing. This is the grout, and there will be a grout rock bond thing. Why is it so critical in determining the shaft friction?" So his question is, why is it so critical in determining the shaft friction? So I was telling, great question, John. The grout rock bond is essentially what ensures the grout sticks to the rock. The stronger the bond, more friction the pile can generate. If the bond is stronger, it can generate more friction. It's all about how the pile resists the axial load applied to it. Here you can see this is the pile. This is the pile thickness. TP is the pile wall thickness, and DG is the grout body, and DS is the sleeve body. This is the sleeve, and this is the pile, and it's a grout inside. These projections are shear keys. We will discuss about this. Okay, but why is the bond strength calculated based on the unconfined compressive strength? You can see unconfined compressive strength. The bond strength is calculated based on the unconfined compressive strength ratios. Isn't that just a measure of how strong the grout is when it's compressed? How does that relate to the bond between grout and rock? Actually, how does that relate between grout and rock bond? Good point. UCS measures the grout's ability to resist being crushed, but it's also an indicator of how much load the grout can transfer to the rock. The stronger the grout, the better the bond with the rock, and that's where we get the shaft friction. So it's UCS that dictates the grout's performance under the load. Here we can see the grout rock bond limitation and grout steel bond limitation. There are two things we need to consider. The grout rock bond strength has been evaluated using the method developed by Apps and Needham in OTC. Grouted piles in weak carbonate rocks. You can see grouted piles in weak carbonated rocks. In this approach, the ultimate friction, shaft unit friction, unit shaft friction. This is the shaft friction. Unit shaft friction for the grouted pile is estimated based on the unconfined compressive strength. So the Fs is a function of unconfined compressive strength. So if the UCS is less than 1, it is a simple multiplier of 0.375 times UCS. And if it is between 1 and 3, there's a formula, it's linearly increasing it. And if it is greater than 3, it's 0.75, it's limited, so it's capped at 0.75. Fs is the ultimate unit shaft friction, and UCS is unconfined compressive strength. We can see the grout steel bond according to the pline pipe connections and grout shear key connections. There are two things. In the pline pipe connections, we can see according to AP strands, the drilled and grouted piles without shear keys. You think this is the important thing. You consider this without shear keys. That's pline pipe. Yes, the allowable axial load transfer is 0.138 and it's 0.184. It's operating in the extreme conditions. So in this one, the drilled and grouted piles, the Fs is limited to the lesser of FGS and FBA as mentioned above. These are the two values, Fs and FBA. So next one is shear key connections. In this one, to optimize the axial capacity of drilled and grouted piles, the shear key arrangement used to prevent failure at grout steel bond. So you can see this is the shear key, and here inside the grout will be there. So this is the steel surface, it will come, right? This is the pile wall thickness. This is the shear key. The shear key is welded to the pile, and inside the grout will be there, and here will be the rock layer also, it will be there. If you see this one, the pile wall thickness, I'm just drawing the pile wall thickness outside the insert pile. Actually this is the socket. In the red color I can say this is the socket, that means drilled inside the rock layer below mud line, and the green color is the insert pile wall thickness, and then here inside it will be the grout, it will be there. So this surface, grout and steel, this is the steel and this is the grout. So to prevent the grout steel bond failure. To prevent the failure at the grout steel bond, the staircase are provided. The staircase arrangement is used to prevent failure at this grout and steel bond. It is commonly observed that the unit in friction is lowest of the grout steel bond at the interface. For drilled and grouted piles with the staircase attached to the outside of the insert pile, this is the insert pile. This is the insert pile. This is the shear key. The staircase. For the drilled and grouted piles with the staircase attached to the outside of the insert piles, the following equations may be used to determine the grout steel bond limitation. So what we are talking about, the grout steel bond limitation. So FGS, if you see 0.138 for operational condition and extreme condition, there are two conditions. So 0.138 and 0.184. So 0.138 we multiply by 1.33, it will come 0.184, and 0.5 into 1.3 also 0.361. That's FCU. FCU is the unconfined compressive strength. This is the minimum we need to consider as 17 MPa as per APR Pitway. And H is the shear key outstand, S is the shear key spacing. That's nothing but, see here, this outstand, this is the H, and one shear key to another shear key. Suppose another shear key is here. The distance between these two shear key, that's the H, yes, spacing of shear key in mm. So with this H by S ratio, H by S, if we outstand it's increasing, means we will get the unit skin friction also higher value, and if say spacing is reducing, that means very closely spaced, means we will get FGS value also higher. The unit skin friction, it will go up if spacing is coming down, and it will go up if H also is going up. It's a H by S ratio. So here we can see the conditions like grout rock bond limitation, grout steel bond. There are two things, grout rock bond or grout steel bond. There are two limitations, and shear key connections. There are three things. Ultimate unit skin friction, FS, that's what we are going to find it on. The grout rock bond limitation, the UCS is a main factor. It depends on the UCS value. FS values are changing, and it is capped at 0.75, and if it is greater than even 3 also. And then unconfined compressive strength, this is also important value, unconfined compressive strength, used to calculate the unit skin friction. And the plain pipe connections 0.138, 0.184 for extreme conditions and operating conditions, it varies. Shaft friction FS is limited to the lesser of grout rock bond or grout steel bond for drilled and grouted piles only. And shear key connections, with shear key connections operational condition, that's 0.138, 0.5 FC into H by S, and H is the spacing, shear key outstand, S is the spacing, FCU is the unconfined compressive strength. It's not 35, it's a 17 minimum as per APR to client, as specified by client, or as per minimum APR between. Here we can see the grout bond, rock bond limitation, grout steel bond limitation, shear key connections. These are three important topics. And purpose, if you see grout rock bond limitation, and this section describes how the bond strength between the grout and rock is calculated. How the bond strength between grout and rock is calculated. Here, how the bond strength between the grout and steel is calculated for the grout steel. Okay. Which is essential for determining the shaft friction in grouted piles. The bond strength is calculated based on the unconfined compressive strength. So if the UCS less than 1.0, shaft friction is 0.375 times UCS. If it is between 1 and 3, the shaft friction increases according to the formula. And if it is greater than 3, its shaft friction is capped at, so capped at 0.75 MPa. So if it is for the plain pipe connection for drilled and grouted piles, do not use shear keys, have plain pipe connections. The allowable axial transfer is 0.138 and 0.184 for operating condition. For extreme conditions, shaft friction is limited to the lesser of grout rock bond or grout steel bond. The shear key connections, to optimize the axial capacity of piles, shear keys are added to prevent the failure at grout steel bond. It is added to prevent the failure at grout steel bond. The shear keys, why do we need to add a shear key? Just to prevent the failure at the grout steel interface, that bond. It is calculated based on these formulas. Fcu is the unconfined compressive strength. H and S are the shear key outstand and spacing. Here we can see, so the UCS controls the maximum friction, but how do we know the exact friction? So UCS controls the maximum friction. How do we know the exact friction? Why does the formula change depending on whether US is lower or above or below 1.0? Great observation. When the UCS is low, such as under 1 MPa, the grout bond is weak. So we use a simple form multiplier, 0.375 times multiplier. If UCS is low, and we use a simple multiplier to estimate the friction. But if the UCS goes up, the friction increases. We use linear increase because the bond strength improves. Because the bond strength improves, we use a linear strength, and that's why we are using that one. Like at UCS over 3 MPa, we assume that the bond strength is maxes out. Bond strength maxes out 0.75 MPa, no matter how strong the grout gets. Wait, so the formula is not just for calculating the friction, but also considering limits of bond strength for safety, right? Yeah, it seems like we are building a safety factor. But why cap it at 0.75 MPa? Why to cap it at 0.75 MPa? Exactly, you are getting it. 0.75 MPa cap represents the maximum bond strength we have observed in practice. We are capping it because that's the maximum bond strength we have observed in practice. At any higher, the grout won't provide any additional benefits. At any higher, it might even cause a failure in somewhere else in the system, like at the steel bond. I see. So we have these limits to prevent overstressing of the materials. But what about the grout steel bond? I'm still fizzy about and how it interacts with the grout rock bond. That's where things get interesting. For piles with plain pipe connections, no staircase, we look at the grout steel bond too. It's essentially the strength of the connection between the grout and the steel pipe, which transmits the load. But for operational conditions, allowable axial load stress is 0.138 or extreme 0.184. So we use this grout steel bond to determine whether the steel pipe will fail before the grout. And how does the shear key play into all of this? So exactly, without shear keys, the bond between grout and steel is weak. So without shear key, the bond between the grout and steel is weaker. But if we add a shear keys, they help transfer more load directly to the grout, so the grout steel bond is not weak link anymore. The shear keys essentially prevent failure at grout steel interface, and the formulas used earlier for shear key connections, they gave us the shear key effectiveness at different conditions, right up to operation extreme. Here you can see as for operational conditions, the grout steel bond strength increases with the shear key arrangements. F is the grout strength, H is the shear key outstand, S is the shear spacing. H, the larger the H and smaller the S, the stronger the bond. Larger H, smaller S, stronger the bond. For extreme conditions, the equation slightly adjusts with a different multiplier. So the shear key arrangement helps us optimize axial capacity by improving the grout steel bond. Shear key helps us optimize the axial capacity by improving the grout steel bond, but we only get a goal. So for the grout steel bond, grout rock bond limitation is capped at 0.75 MPa to avoid overstressing. The key takeaway here is balancing these bond strengths. Grout rock, grout steel. Our goal is to get maximum axial capacity without overstressing any part of the pile. I think I've got it now. The grout rock bond, shear keys, grout steel bond. It's all about making sure the pile can handle the load in the most efficient way possible without any weak spots. We will see one problem. We are designing the grouted pile in a weak carbonate rock with following parameters: UCS2 and grout compressive strength. Unconfined compressive strength is different, grout compressive strength is different. FCU and UCS, these two are different. So UCS is 2 and unconfined compressive strength UCS is 2 and compressive strength of grout is 30 MPa. Shear key outstand and shear key spacing H and S. We need to calculate the following: ultimate units in friction, Fs we need to calculate. Grout steel bond for both plain pipe and shear key connections, with the shear key, without shear key, under both operating conditions. Calculate the grout rock bond limitation. First we will calculate the grout rock bond limitation. We use a UCS value to calculate the grout rock bond strength. The UCS is 2.0 MPa. We are in the range of 1 to 3, so we use the formula applying 375. Then we will get this value. So this becomes the grout rock bond 0.5625, and calculate the grout steel bond with the plain pipe connections rate for 0.138 and 0.184 for different conditions. And so we have these values, and next is calculate the grout steel bond for shear case connections. We have the formula. Let's calculate the grout steel bond for a pile with shear case. So we can use these formulas and substitute, plug in the values. You will get the value of 0.7 and 0.936, but still it is capped at 0.75. We have to limit to 0.75. It's another example. So step 4 is the limit condition. We can calculate